Hello students, welcome to module 11. In this module we are going to discuss method of sections. This is a very simple subject. No need to worry, you will be scoring 100 out of 100 from this topic. Okay. So whatever might be the question, the first step was to find support reactions, right? As soon as you see the question related to method of sections or method of joint, find the zero force members if you could first of all. After that, because it is not a process, right? So it is a hack. Hack helps you to solve the problem easily. Okay. Once you get into the problem, the first step should be find support reactions. Fine. So after finding the support reaction, you have to cut through the member in which you want to find the force. For example, if you are solving this question, force in the member CE, he is asking us to find what is the force in the member CE. Where is our CE member? This is our CE member, right? So how to get the force? Find the support reactions and then cut the member. Okay. So we can cut maximum of 3 members. It is not mandatory. We will solve the problem where we will be cutting more than 3 members. But in exam, select the structure like that you can cut maximum of 3 members only at a time. Okay. So now let us find the support reactions. First of all, you can see we have the load of 10 kilonewton. If there is a 10 kilonewton which is equidistant from both the sides, 3 meters and 3 meters. So what should be the support reaction? Support reaction will be 5 kilonewton upwards. Very simple, right? You need not find support reactions in this question because you already know if it is equidistant, it will be same 5. Even in case if you don't know how to calculate support reactions, I will teach you in some bending moment diagram and shear force diagram chapter. Don't worry. But I hope as you are engineering students, you know how to find these support reactions at least. Okay. So let us, if you don't know support reactions, this is my support 1, this is my support 2, right? So R1 and R2 let be the support reactions in vertical direction. So what I will be getting? I have 3 equations. Sigma x is equals to 0, sigma y is equals to 0, sigma m is equals to 0. Let me use sigma y is equals to 0. What I will be getting? R1 plus R2 is equals to 10 kilonewton. If I use sigma m, I can use sigma at this end or I can use at the second end also. Let me use at first end. What I will be getting? 10 into 3. If this is 3 meters and this is also 3 meters, right? This is a clockwise movement. So I'm assuming clockwise movement as positive and anti-clockwise movement as negative. Okay. So what I will be getting? 10 into 3 minus R2 into 6 is equals to 0. So what is my R2 value? R2 value is 10 into 3 which is 30 divided by 6. You will be getting 5 kilonewton. If R2 value is 5 kilonewton, just substitute it in R1 plus R2. What will be your R1 value? R1 value will be 10 minus 5 which is again 5 kilonewton. Simple enough. So you can find support reactions like this using equilibrium equations. Okay. Just give me a second. Let me erase this. Just give me a second. Let me erase this properly. Okay. So what is the second step? You have to cut through the member, right? You are cutting through the member like this. I have already drawn the diagram, so no issues. You can cut through the member like this. Okay. Once I cut the member, you can select either the left part or the right part. Up to you. Select the part in which you see less amount of diagram. In left hand, I have large amount of diagram. In right hand side, I have less amount of diagram. So I am obviously opting for the right hand side of diagram. Okay. When I opt for right hand side of diagram, I will get something like this. Agreed? ऐसा ही कटेगा ना? 1, 2, 3. Sorry. Like this, right? Agree? So we have like 3 forces. As I have cut 3 members, I am getting 3 forces: CB, CE and DE, and I have a support reaction of 5 kilonewton. Okay. So I am giving a very important note. Make a note, write down in your notes. You would have the hard copy, right? In the hard copy of the notes, make a note. Whenever you are analyzing an inclined component, always use sigma y is equals to 0 in section method of section. Okay. So because see here I have 3 unknown forces, right? But 2 of the unknown forces doesn't have sigma y component. See BC, this is perfectly horizontal, right? So y component is 0. And this DE, it is also horizontal line, so y component is 0. So y component is present only for CE, right? For the right hand side diagram to be in equilibrium, your sigma y should be equals to 0. Therefore, FCE, this component, it's vertical thing. FCE cos theta here it was given as 45 degrees. should be equals to your upward load, which is 5 kilonewton, to make sigma y is equals to 0, right? So what is your FCE value? FCE value is nothing but 5 divided by cos 45, which is 1 by root 2 is equals to 5 by root 2. कितना simple है भाई, कितना simple है. There is nothing. You just have to cut the structure. Now you have to analyze either for the right hand part or for the left hand part. You will be getting your answer. Okay. For the left side, you use sigma x is equals to 0, sigma y is equals to 0, sigma m is equals to 0. You will get your answer. For the right side also, again you have to use sigma x, sigma y, sigma m, based on the component in which you want, right? You will be getting your answer. So now let us see the question. यहाँ पे मैं एक important point stress करना चाहता हूँ. Even when you cut the member, okay, just let us see the example in this question only. So when I cut the member, right, let me erase this, let me erase this, let me erase this, give me a second. Yeah, see, the point which I want to make is, यहाँ पे I am cutting the structure into left hand side and right hand side, right? So as you saw, I am cutting it to the left hand side and right hand side. Okay, when I am taking right hand side, I got forces like this. Okay, what are the hinges I have? I have hinges at B, A, E, C, D. Okay, you need not use this sigma x, sigma y, sigma m equations only to the right hand side. Okay, for the right hand side you can apply sigma x, sigma y is equals to 0, but you can use sigma m anywhere on the structure, because whatever point you take, it is a hinge, right? For example, I can take sigma m e is equals to 0. Okay, I can take me is equals to 0 and I can write an equation that 5 kilonewton, I have 5 kilonewton load, right? For the right hand side structure, what will be my equation? FCB this force, FCB this force into perpendicular distance, whatever, let that be L1. Okay, see this point, FCE, it is passing through it, so perpendicular distance is 0. FDE, it is passing through the point E, so perpendicular distance is 0. What is the force left on the right hand side? Only upward force, support reaction 5 kilonewton, right? So this is a anti-clockwise and this is also anti-clockwise, so both positive. FCB into L1 plus 5 kilonewton into this distance was 3 meters into 3 meters is equals to 0. From this equation you can get FCB. All I want to say is, whatever you, even when you are cutting the left hand side and right hand side of the structure, you can take moment on whatever hinge it is available for you. Okay, just see which hinge will help you in solving the problem, and you can apply sigma m is equals to 0 at that hinge for the right hand part or for the left hand part, and you will be getting your answer. Fine. So see this question. Now solve this question using that concept. I have to find FAB, force in member AB. Where is my AB? This is my AB. Okay, so obviously I will cut the left hand side and select the left hand side structure because it is simple compared to right hand side analysis, right? So I am taking left hand side. So what I will be getting? I will be getting something like this, FAB. I have an inclined component, inclined member FAD, and I have something like this FCD. Agreed? And the load is here acting 20 kilonewton at this point. See, if you see properly, these two forces are meeting at the point D. If I take moment at point D, these two forces will be nullified, right? Because if I am taking moment at D is equals to 0, so these two forces perpendicular distance with the point is 0, right? So force into distance, it will be 0, moment is 0. So only forces which are producing moment are this force FAB and this 20 kilonewton load, right? So at the point D, this is moving clockwise. I am assuming it as positive. FAB into perpendicular distance, it was given in question as 3 meters. So FAB into 3 minus, because at the point D, this 20 kilonewton load is acting like this, right? So it will move in anti-clockwise direction. So what will happen? 20 into the perpendicular distance was 3 again. So on analysis, what you will be getting? You will be getting FAB is equals to 20 into 3 by 20, which is 20 kilonewton. Okay, so as I got positive value, my assumed direction is correct. What was my assumed direction? My assumed direction was it was moving away from the joint. If the force is moving away from the joint, then what is it? Is it tension or compression? It is tension. Therefore, we have to mention 20 kilonewton tension. That's it. You will be getting your 2 marks. Fine. Very simple, right? Now let us see this question. Find the zero force member. What do we have to do? We have to find how many zero force members are present in this diagram. Okay. So start from the joint which has 2 members first of all. So it has 2 members and no external load. So what should be the force? 0, 0. Okay. Now you can ignore these 2 members. Okay. Now it is something, this diagram up to this part, it is similar to this thing, right? Now it is very similar to this thing. Agreed? See, now this force 1 and 2 are collinear. So whatever force present in the member 3, it should be 0. I hope you remember, right? If 2 forces are collinear, the third force which is making any angle with these 2 forces, what should be the value of it? The value of it should be 0. Agreed? So this is 0. So you can ignore this member now. Fine. So again, it is very similar to this thing. Now the load is acting here. Again these 2 members 0, 0. Again you can use 2 members are collinear. So again this force is 0. I hope you understood, right? And this will continue. Let me show on this diagram itself. So now this is 0, 0, you know. Now you can ignore this member and this member. You can see 2 members are collinear. So obviously this force should be 0. Now you can ignore this member and this member. Now see, now it is like 2 members meeting at a joint and no external force because these 2 are 0 forces. So it is again similar to this thing with no external force. So again 0, 0, 0, 0. Again the load is being transferred to this member and these 2 forces are collinear. So again this force is 0. As this force is 0 at this joint, there are 4 members meeting, but these 2 are 0 forces. So it is similar to again two members meeting, no external load. So 0, 0. Again these 2 forces are collinear. So this is 0. Done. So what is left? One more member is left. You can see it is directly going to this joint. You can use sigma x is equals to 0 at this joint, and you will be getting this force is also equals to 0. So how many 0 forces are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So answer is 10. You have to be very careful. Option ऐसा देगा कि 8, 9, 10, 11. You should be very accurate. On practice only you will be getting this accuracy and writing the correct answer as 10. Okay. So don't make any mistakes. Take your time and excel this chapter, because this chapter there is a chance of making mistake, but this chapter is very simple. Don't lose marks from this chapter. Okay. So let us see the next question. Now let us see the second question. Again we have to find number of zero forces. So do you find any 2 joints or any 3 joints in which 2 are collinear? Is such type of joint present in this? Here 3 are meeting, here also 3 are meeting, here 2 are meeting, but there is external load, so no use. So we can't just by seeing say these forces are 0 force member in this question. Okay, we can't say. So what we have to do? We have to analyze it. How to analyze? Find support reactions first. We have to find the support reactions first, and we can start from these joints. Okay, or we can also start from this joint, because we can use sigma y at this joint and get the force in this member, but again it will get complicated, right? So let us start from the support so that it will be easy for us. So how to get support reactions? Sigma V or sigma y is equals to 0. So VA plus VB is equals to 10 kilonewton and sigma m is equals to 0. On solving, I have solved here. You can check. I got VB is equals to 20 kilonewton and VA is equals to minus 10 kilonewton. Okay. So VA was minus 10 and VB is plus 20. Okay. Download load is 10, right? So it is also minus 10. So balanced. 20, 20 balanced. So I can start from these bottom joints now. So let us start from this joint, because I know here there is no force in x-axis, right? So I can start from this joint. So use sigma x is equals to 0 at that joint. So what you will be getting? If I use sigma x is equals to 0, then the force in this member FAB, for sigma x to be 0, it should be equals to 0. So I know this is a 0 force member. So one member eliminated, right? Now if you could eliminate this number, this is a 0 force number, right? So ignore it. Now you can see there are two forces meeting which are collinear, support reaction, and this force A, say this D. Okay, the force AD are collinear. So this force, whatever it is making some angle, so it is 0. So I could eliminate two members. Now very similar to that, as this is 0, again sigma x, we can eliminate this number, right? So at this joint, if I use sigma x is equals to 0, obviously this member should be equals to 0, right? Only then sigma x is equals to 0. 0 force 0 should be equals to 0, therefore this is 0, obviously, right? This is 0. Again, now this member and this member are collinear, and there is only one member passing because this member is already 0. You can eliminate it. One member passing, so obviously this is also 0 force carrying member, right? So if you could neatly represent, you can represent this diagram like this, okay, with 4 0 force members. Okay, so this member was carrying some force and it is making some angle, right? So this won't be 0 force member, as this is not a 0 force member. This will not be 0 force member because when you are writing sigma x at this point, so let this be some kg, f kg cos theta should be equals to this kf, right? If I am saying this is kf, should be equals to kf. fkg is not equals to 0 because sigma y at this point is not equals to 0. So fkg is not equals to 0. My fkf will also be not equals to 0. So this is not a 0 force carrying member. 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 So how many 0 forces are there? There are 4 0 forces. Okay. Practice करना, ये क्वेश्चन 2-3 बार practice करना, you will be perfect in it. Okay. Now this is a similar question which you have solved, right? Find the forces in BE. Where is BE? This is BE, BC and CD. Where is BC? This is BC and CD. Okay, in a very similar question, instead of 10, it was given P. Now in this question, I am giving P as 10, but solve this using solve this using method of joints only. Okay, solve this using method of joints, and this is your homework. Just in place of P, I have given the value 10 so that it will be experienced, because this problem is an important problem for your ESC, GATE and also state PSCs. Okay, so please do that problem. And very important note I am going to give you. So first of all, see the note here and then I will explain you this question. Okay, so in case of a panel shear force, in case of panel shear force is 0 in any panel, then force in inclined member in that panel is 0. I hope you didn't understood anything, but first let me explain you what is panel. So this is called as panel. You eliminate this triangular part. So all the rectangular parts, if you are considering a truss, right? All these rectangular parts, we call it as one panel. Okay, even a triangular part is called as panel, but in problems, we generally take these rectangular parts as one panel. Okay, if the shear force in between this panel is 0, okay, then the inclined member will be carrying 0 force. For example, if see this question, I will explain you this question itself. So here I have W force, here I have W force. So what will be the support reaction? As the force is equidistant, so this will be upwards W support reaction. This one will also be upwards W, right? Agree? So what is the shear force in this member? In this section, shear force is W. But in this section, I have upwards W minus downwards W. Upwards W minus downwards W. So my shear force is 0. So in this panel, my shear force is 0. If my shear force is 0, the force in inclined member in this FCF, it is equals to 0. Okay, you need not solve this. You need not use method of sections or method of joints. Just by seeing the shear force, if there is any shear force, then only you go for method of joints or method of sections. If there is no shear force, if the panel shear force is 0, panel shear force means shear force in this section, in this panel, okay, because it was W here, support reaction. So in this panel it was W, in this panel W minus W, 0. So if there is shear force 0 in the panel, then obviously the inclined member force is 0. Very important note, super important note, give it 5 star. It will be asked as an objective also, and it will be used in solving many of the questions. Fine. Now based on that, can you solve this question? What is the force in member FAB? So where is my member FAB? This is my member FAB. Okay, you can see here I have 20 kilonewton, here I have 20 kilonewton, my support reaction is 20 upwards, 20 upwards. In this, what will be my shear force? Shear force will be 20, right? 20 upwards. But here, my shear force is 20 upwards minus 20 downwards, which is equals to 0. So my panel shear is 0. Therefore, my FAB is equals to 0. How I got 0? You can just remember it as a point FAB is equals to 0. But if you want mathematical expression, I have given mathematical expression also. You can use sigma V is equals to 0, right? Use method of sections. Use method of sections. So if I cut, this is my left hand side, right? So this is my left hand side. How it is? It is something like this. A, P, I have cut the member like this, right? Agree? So this was my structure. So if I am using sigma V is equals to 0, only force which is going upwards. Here I had 20, here I had 20, right? So 20-20 balance, right? What is the force going upwards? F A B. This, if this is the theta, vertical will be FAB sine theta, right? Plus 20 minus 20 should be equals to 0. 20-20 cancel, so FAB sine theta is equals to 0. So FAB is equals to 0. Mathematically like this, but you need not solve mathematically always. You just have to do FAB. If there is any inclined member in a panel which carries 0 shear force, then that inclined member will be a 0 force member. I hope it is clear, right? Now I am teaching you a very important note. Give it 5 star because this is very important for PSC exam, state PSC exam, Bihar state PSC, Uttar Pradesh state PSC. This question has asked numerous number of times, and this is regarding conversion of beam action into truss action. For example, if I have a beam like this and a load is acting, okay, what will happen? The top, it will bend like this, right? Obviously, it will bend something like this. As soon as load is acting, the top part will be in compression, it will get compressed, whereas bottom part, it will be in tension, right? As it will be trying to get elongated. This is what happening, right? So similar to the truss, when the load is passing through the truss like this, what will happen? The same thing happens. For example, if the load is here, so this compression, bending compression stress is taken up by the top cords, okay, and this tensile stress is taken up by the bottom cord, okay, and the shear force whatever is there, it is taken up by the inclined members. I hope it is clear. Now read the point, you will understand. The bending compressive stress is resisted by the top cord by axial compressive stresses. Okay, bending tensile stress is resisted by bottom cord member as axial tensile stresses. Okay, जो भी bending tensile stress था because of the bending action in the beam. Here we don't have bending action in truss. So how is it converting? This bending action is converting into axial tensile stress. Fine. And in the top member it is converting into axial tensile stress in bottom and axial compressive stress in the top members. And inclined members, they are taking shear force. Okay. The shear force in the beam is resisted by vertical and diagonal members in the form of panel shear. Okay. That's why if the shear force in the panel is 0, then the force carried by the inclined member is 0. Okay, now you realize, right? Shear force in the beam is resisted by the vertical and diagonal members in the form of panel shear. That's why if panel shear is 0, then the vertical force carrying members or diagonal force carrying members is 0. Done? Now let us see the question related to the text. So he is asking us to find members having 0 forces. Okay. Now let us see if there are any 2 members with no external force. Yeah, I can find 2, right? And here also at this corner, I don't have anything. Now let us see if there are any axial forces. 2 axial forces and third force meeting making some angle. So is there availability? Yeah, here I found 1. Okay, this force is making some angle, so it will be 0. As there is no external load. If there was some external load, obviously it won't be equal to 0, right? So we already know this concept. So I got 5 members. Now let us see panel shear. We have just learned about panel shear, right? So in this panel, my shear force is 10. In this panel, my shear force is 10 minus 10, 0. How I got 10? Support reaction is 10, right? Here it is 10, 10. So load was 20. As it is equidistance, I will get 10 here and 10 here at support reactions. In this panel also, my shear force is 0, right? In this panel, my shear force will be again 10, right? Minus 10. If I am taking here plus 10. Okay. So in these 2 panel it is 0, right? Therefore my Inclined member will carry 0 force. So how many 0 forces are there? 1, 2, 3, 4, 5, 6, 7. So we are done. You will be getting your 2 marks. So simple, right? Now let us continue with the next problems. Again, a very important question. This question has been asked in ESE and GATE both. So in this question, he is asking us to find force in member AB. Whenever there is a question like this, force in member AB, what method you have to go? You have to go for method of sections. See, while solving method of sections, now tell me which section you can take. See, however you cut, you are cutting through 4 members in this. Just see, 1, if you want to cut like this, 4, right? If you want to cut like this, you again have to go 1, 2, 3, 4, 5. Okay, however you are cutting, you have to cut more than 3 members if you want to solve by method of sections, right? So I am taking the risk and trying to cut more than 3 members in this question. Okay, this question is one of its type. Okay, you won't get these questions repeated. This is one of its type, so make sure you practice this question 2-3 times. Okay, if you are practicing this question 2-3 times, I am sure this question will be repeated in some of the exam for sure. Okay, they might be asking for some PSU exams or PSC exams. Okay, these questions get repeated. These questions are one of its kind, right? So the questions which can be generally formed, they can twist up to you, right? They can twist up to their talent. But these questions which are already twisted, they don't twist with these questions. They give as it is. So these questions which have appeared previously in ESE and GATE, these do get repeated in so many examinations. Okay, so just practice this question twice or thrice. So what I'm doing is I'm cutting through members something like this, and I have said we have to cut the plane, but I have nowhere said the plane should be perfectly straight. You can cut up to you. You can cut like this also. It doesn't matter. You can cut. Okay. The section plane depends on us. You decide which is best. Okay. So this is very important, which you have to remember. It is nowhere mentioned that the section should be like this or like this. Okay. You can select the shape of your section. It doesn't matter. So I'm going like this. Why I'm going like this, you will understand in no time. Because when I'm cutting a member like this, so you can see the bottom, it is something like this when I'm cutting. Yeah, agree. I want this member FAB. So I have forces here. I have the point G, and I have force going here, which is force HG, right? This is my H, this is my G, force HG, right? So this is my G point. So if I take moment on this G point, this force is passing through the G point, this force is passing through the G point, this force is meeting at G point. So I will be getting, if I am using equation sigma mg is equals to 0, I will be getting very easily my value of FAB. Okay, so what you have to do? You have to cut the member like this, and you can take the bottom part or a top part. I am taking top part because if I am taking the bottom part, so if I am taking bottom part, I have to solve for reactions also. Right, you have to solve for these reactions, and then you have to take top part. If I'm take the bottom part, if I'm taking the top part, I will be getting only this part, and only forces which are acting at G and has a perpendicular distance will be FAB into what is this distance? This distance is 4 meters, right? Is equals to 40 kilonewton. It is acting clockwise, and this force is acting anti-clockwise. So FAB minus 40 into what is this distance? It is again 2 plus 2, 4 meters. 40 into 4. So FAB is equals to 40 into 4 divided by 4, which is again 40 kilonewton. So assumed direction is correct. Assumed direction is away from B, which means tensile force. 40 kilonewton tensile is your answer. Okay, very simple, right? So there is nothing much in this question, but whenever you see the question like this, if you don't know, if you haven't thought this method, okay, if you haven't thought this question, you will make mistake in this question for sure. No one can solve this question, right? So everyone will be searching for the plane in which he can cut 3 members. But the person who doesn't know that you can cut more than 3 members also, you can cut the plane not only straight but also curved in a curved manner. Only those persons can solve this question. I hope you can solve a similar question if he is given. Okay, there won't be much changes. Okay, he will only play with the height. In this he has given 4 story, right? In some question he will give only 2 story. or in some question he will use 6 or 7 story. Okay, only height is changing, but this question remains same. Okay, the model remains same. Now let us see a very simple question and end this topic of method of sections. Okay, so here what is happening, he is asking us to find what is the force PQ. Where is PQ? This is force PQ. Let us give a direction. It depends on us, whatever direction we can give it. Let us give the direction like this. Okay, I have given a compressive force going towards the joint. Now let us see if it is correct or wrong. How to get the value? We have to apply equilibrium equation. Let us apply equilibrium equation at this joint Q. Okay, first equation I am applying is sigma y is equals to 0. Okay, if I apply sigma y is equal to 0, I will get the force in this member. So what is that force? F is equals to F RQ cos 45 or sin 45. If I am taking this angle as 45 degree, because it is L and L, right? So 45 degree. So I hope you know, right? If it is L, what should be the angle? Angle should be 45 degree. So I have 45 degree cos 45. So this will be sin 45. This is sin 45. So F is equals to FRQ sin 45. What is my FRQ value? It will be F by sin 45, which is F by 1 by root 2 or F root 2. Okay. So my assumed direction is correct as I got positive value. I have assumed it as tensile force. So I got the right answer. So let me erase this again so that we can have more clarity. Okay. So I got the value as F root 2. Now I have to get the value of this PQ. So what I can do, I can use sigma x is equals to 0. What is the F component of FRQ? FRQ cos 45. See, this is tensile, right? I have assumed this as compressive. So minus FPQ is equals to 0. So what is my FPQ value? It is FRQ cos 45. What is FRQ? F root 2 into 1 by root 2, which will be F. Okay. So your PQ value is F and assumed direction is correct. So you have assumed pointing towards the joint. So it is compressive force. You can write PQ is equals to F compressive. Okay. If direction compressive is not given, you can go for minus F. If compressive is given, you can write F in brackets compressive. Okay. So this ends the topic, and from now we will go to the part 2 of this chapter. In this I will teach you what is the deflection in the trusses. Okay.